So, good morning, good afternoon, or good evening, depending on where you're joining from. A very warm welcome to each of you. It's truly a privilege to host such a diverse and international audience, and we are grateful that you're taken time to be with us today. So, this webinar is a wonderful opportunity for us to connect, share ideas, and gain valuable insights. And it's your presence and participation that makes it more meaningful. So to ensure a smooth experience, all participant microphones will remain muted during the presentation, except for the speaker. At the end of the session, we will have a dedicated Q&A, and you can either unmute yourself to ask questions or simply drop them in the chat box. And you may also email us using the contact information shared on the screen. So today's webinar will focus on transforming electrical design with BIM, enhancing project outcomes with Revit, Revit tools, components, and workflow. So before we dive into the session, I would like to invite Anantha Krishnan, our project manager and head of plant engineering department, and who has been with us APA for over 10 years, and he's to introduce APA engineering and walk through the upcoming slides. Anantha Krishnan, over to you.
Thank you, Pratish. Warm greetings to everyone present. So about APA. So we are a 25-year-old company, 500 people strong, headquartered in Chennai, India. We serve clients from the USA, Canada, Germany, Netherlands, and Australia. We are ISO 9001 certified for quality process and ISO 27001 and TSAC certified for information security. So coming to our divisions, we have 4 divisions. So sourcing. In sourcing, we what we do is like we identify suppliers for the manufacturing needs of our customers. So we do inspection at all stages of manufacturing. We do a pre-dispatch inspection, and then we optimize the logistics, and also we support on the shipping and delivery of the product to our clients' doorsteps. And regarding engineering, we'll be seeing a bit more in detail in the upcoming slide. Moving on to compliance. In compliance, we offer software products and services to clients, helping them to adhere with the product compliance requirement like IMDS, conflict minerals, ROHS, etc. And in our technology department, we support cataloging, and we also provide services to improve the enterprise workflow through custom built IT products and services. So moving on to our engineering division. Our engineering division is a 70-member team comprising of mechanical, electrical, and electronics engineers. And our service categories can be classified into five verticals, which is product engineering, manufacturing engineering, building information modeling, digital modeling, and embedded engineering. So with relevance to today's webinar, we can take a look at building information modeling in a bit more detail. So in building information modeling, we support various disciplines. Say for example, in mechanical, we do HVAC duct routing, equipment layouts, custom built fans, and we provide detailed drawings for all these activities. And then coming to electrical domain, we support conduit design and detailing, as well as the control panel layouts, all equipment layouts in a building, and also schematic preparations. And then we support 3D modeling and 2D services for steel structures, and also analysis for the same. And also we support piping layout and drawing creation. So moving on. So in today's webinar, we are going to see how Revit Electrical can add value to your electrical BIM projects. So we'll be starting with a small introduction to Revit Electrical. Then we'll move to the tools present and common components. And then we'll move to a small workflow demo. And then to the final document drawing preparation, schedule creation, etc. And then we'll see how interference checking is done in Revit. And finally, we'll have a Q&A session where you can raise your queries. So now, what is Revit Electrical? So Revit Electrical is a part of Autodesk Revit software, which is basically a building information modeling software. This is used predominantly by electrical engineers and designers to create 3D models of electrical components like, say, light fixtures, sockets, cable trays, conduits, etc. And also to prepare 2D drawings as well as final bill of materials, schedules. So this is what Autodesk Revit Electrical does. So moving on to the benefits of Revit Electrical, uh, first we can see about automated scheduling. So a schedule is nothing but a list or a table, imagine an Excel sheet containing all the information about the electrical items present in a particular building. So in Revit, what happens is all the information related to the component will be stored in the 3D model, and with few clicks we can auto generate the Excel sheet, which is called the schedule. So how this helps is like any update we do in the model will be automatically updated in the schedule as well. So we don't have to do any kind of manual work for the schedule preparation. The next benefit is like seamless coordination. So as you know, in a building there will be other systems like HVAC, piping, or structural along with electrical. So using Revit we can work simultaneously in the same building. So the model will get updated in a real time. So this helps us to identify any type of clashes during the design stage itself, and so we can avoid this in the construction phase. And then we will see special components. Special components are nothing but 3D objects present in Revit. So what this does is these components will have data stored in them. So for example, if it is a if the component is a light, for example a light fixture, that will have data like the dimensions of the light, the name of the light, the watts, and who is the manufacturer. All these will be stored within the 3D model. So this particular block is called as families in Revit. So families are nothing but data rich blocks. So we'll move on to the tools, general tools we use in Revit. So first, the project browser. A project browser is nothing but a central hub to navigate through the entire project or building. So in the project browser, you can see, you can easily go to any floor in the particular building, any domain as well, like say mechanical or electrical. So any domain you can go, and also you can see all the panels generated. So all this information will be collated in the project browser. So basically, it is used for navigating in the model. Then electrical settings. So electrical settings are it is a tool that helps us to add in the standards that needs to be followed in the particular project. For example, if we have to freeze the voltage to be used in the project, we can add it up in the electrical setting, and that will be followed throughout the project. And then circuit creation tools, which is nothing but it will help us to loop in all the devices easily through simple clicks. And then panel tools will help us to place or locate the panels and also generate schedules from the panels. And moving on to some major components or families in Revit. So these are some of the electrical components, say like lighting fixtures, receptacles or switches, then electrical equipments like say a transformer, a UPS or a generator, and cable trays, conduits. And also we can prepare our own custom Revit families. And now we will, this is what you see on screen is the basic workflow in Revit, project workflow. So from the initial project setup to the final drawing or sheet preparation. So we have a small demo video showing the Revit workflow. To speak for the demo video, we have Vijay Kannan. He's one of the project leads in our engineering division. He's an electrical engineer with 9+ years of experience in building information modeling, particularly for electrical, and also in coordinating with other MEP services. And he has handled various projects for residential buildings or commercial ones like hotels, and also has supported wire and cable industry and solar energy structure. Now, Vijay, over to you for the demo.
Thank you, Anand, for the wonderful introduction. Hello, everyone. I will see the demo. I will start the demo. Here in the Revit model, you can see the project browser here. As we before said, this project browser used to navigate through the floor plan, the overall floor plan, and also segregate the discipline wise. For example, it is a electrical discipline or mechanical or plumbing. And also we can segregate service wise too. For one more example, for it's electrical means we have a lighting, power, like cable management and other services. And also below you can see the in the project browser schedule quantities like sheets and the panel schedules and the equipment schedules, the whole the project browser using to navigate the through complete models. Now we can see the top area. It's called a ribbon plate. In top here we have a system, insert, annotative. We have many different tools we have. In this webinar we are going to see the system tab, particularly electrical. Here we have HVAC, mechanical, plumbing, but we are going to see the electrical tab. In this electrical tab we have a like electrical fixtures, lighting fixtures, communications, data, then security. Then these are the electrical components like families. uh, we'll see the electrical settings too. This is the electrical settings tab. In this electrical settings we have wire settings, wire type settings, like voltage definition, voltage distribution systems. So this initial setup for the electrical settings. So we have to set up the overall electrical settings, and we'll see the voltage settings, because some region they will follow the 120. Suppose it's like a US, UK, they'll follow the like 120, 108 voltage. Suppose it's a Middle East 230 to 240, like that. Uh, can you run the video? I think it's paused now. Yeah, thank you. So here voltage definition, you can see the 120, which was I before said, 120, 208, 240, 277. Based on the region we can set it. And the below we can see the distribution system. Distribution system, nothing but here we can make a based on the region. Here we can make 3-phase or single phase. What is the wire type? Then what? How many wires we are going to use? Line to line voltage, then line to ground voltage. We can fix it here. Then we are going to see the cable tray settings, like a size. Some project they will use a different sizes. Based on the project we can add the sizes. Like for example, we'll use a different sizes, we can add size. Same like a conduit settings also, we can add more sizes. And also material also we can change it, say PVC or is a GI or EMT, whatever, we can add the settings. This is a initial setup. The setup will be maintained throughout the projects. Then we are going to see the components. Components means nothing but this panel. For example, this panel, we have information in this panel. You can see the right hand side, the properties. This is a parameter properties. In the properties we have a panel voltage system, then the dimension, then who is that manufacturer, then the identity data, then facing data. We have more information in the properties. Also we can customize the panel. For example, the dimension will be changed based on the project. So we can easily customize. And if you are going to customize the electrical connector too we can customize, like it is a 3-pole or single pole, or it's a different load classification, or it's a what kind of a apparent load we can fix it with the power factor value we can follow. We'll close now this. For example, I will show you one more components like light fixture. So light fixture, in this light fixture, this is a 1200 mm 34 watts light fixture. In this light fixture we have a you can see the properties. We have a system name, then circuit name, what is the dB feed from the light, feed to the light. Then here we have what is the weight of the light, what is the measurement of the light, who is that manufacturer. Because this is not a simple block, it is a data rich block, it's a with information block. In the Revit we called families. Next we'll see the receptacle family. This is a 13 amps unswitched fused spur outlet. In this spur outlet for using for some emergency purpose, here you can see the system type is emergency, we can provide the system type. Then whatever the information we give, we can show to the display like a tag. In the DB we provide the DB name, it's a distribution board C27 ground floor 01. You can see the properties DB name in the general below. DB name is a distribution 27 G ground floor 01, and also EDP. Whatever the information inside the DB we can show it to the floor plan. Then we are going to see the circuit creation. This is very interesting tool on Revit. I will select the 3 power socket, then I will give a power. You can see the top, we can see the power. When we kick the power, we can create a arc wire. It's an automated loop. This automated loop, it's connected to the below electrical room DB, distribution C27 ground floor 01. This is automated progress. And also we can see the power is connected to where is the DB, the DB name we can see. We'll see the one more example for the lights. This is the general power socket. We'll see the light fitting now. In here we have 4 types of light, 4 different category light. We'll connect a light together. I'll make a loop now. Then now it's connected to the DB27 ground floor DB. You can see the panel name and the system selector, means circuit name. And I can create a new DB panel schedule. Above you can see the system default template panel schedule. Now we created a total 3 circuits, A1, B1, C1 circuits. In the A1 we have created a lighting, it's a 20 ampere, and we can see that it's completely selected. We'll see the one more example. These 4 lights we have here. Now we have a 3 allotted. One is spare, A2 is a spare. Now we will add to the circuit to the A2. We'll connect that same method, arc method. Then I will check the circuit name, DB name. Then we'll check the system selector. It's a A2. Because that space we have, so we can allot the space to A2. It's a general lighting. So we can load classification and MCP value also. You can see the top of the area branch panel name is in the panel name. It's reflected to the panel schedule. Also, I will show you the receptacle, general receptacle. Before we'll see the circuit naming, because this wire we are not give any input on the circuit, because automatically taken what is the circuit is connected to the DB. The lighting is connected to the A2. But when we are giving the tag, it's automatically coming tag, like A2, C1, the circuit name. Then we'll see the receptacle. So receptacle, we'll make a power now, the same method, arc wire. Then we'll see the electrical circuit, the DB name. Then what is the name is B2. We'll make a tag, it's a B2. When we are going to check the panel schedule, here the general power socket, it's connected to the load 100 volt ampere. That's a 20 pole, 20 ampere breaker. Then we'll see the We have to do the circuit for this whole floor plan. Then we'll see the next section, elevation of the electrical room. We'll make a new section on here, one wall. I will just trim the view, because we are going to see the only one, that wall only. As before we said, the floor plan is connected. Every floor plan is connected. Now we are going to see the ground floor only. In the ground floor we have a 4 panels. You can see the 4 SMDBs, and here we have energy meters. And in the floor plan we named DB27 ground floor. It's automatically named here also. Here also we can make a annotation works. For the submission purpose we can make a annotation, because when we are make the floor plan, any components, electrical components, is automatically reflected to the 3D and section. When we click here, it automatically selected to the section, because it's all single family. It is just showing to the section. And also here we have a big panel. Here also same method to information, we can provide the whole information in the big panel. Now we can see the project browser in the left side. Here we have a panel schedule. Under that project browser we can see the panel schedule and equipment schedule. Now we are going to create a sheet setup. We are going to see the sheet setup. We'll make a new sheet. We'll just click. You can see the overall the sheet is a title block. I will just drag and drop the panel schedule. Nothing, single click I can drag and drop. Here also I can drag and drop the electrical equipment schedule. So it's very simple to work and easily automated creation. And here you can customize the title block. If you want to add logo, if you want to add company logo, or if you want to add a naming, you can see the under the sheet project browser, under the sheets unnamed 102 is unnamed. Now we imported two categories, panel schedule and electrical equipment schedule. Also we can export the sheets. Like if you want to export the PDF, we can export it. Like if you want to set the paper size, like A3, A4 or A0, A1, whatever size we can set up here. Also if you want to export another format like a DWG, or it is a, DXF, or it's a NWC, we can export it. This is a CAD format. You can see the CAD formats in the left hand side top. Also we can generate a report with some rendered images. So this is a export. We have some few format to export. Then we'll see the next. We'll move to the floor plan. We'll see that I want to show you the 3D view, how the 3D view was there. I will show you. This is a drive-through area. I will select these slides. We'll check the 3D model. This is our 3D model. You can see the 3D model, the lights was selected. So when we selected the 3D model, when we selected the floor plan, it automatically selected to the 3D model. You can see the generator also, and here we have a small other lights. Before we make a section, like we make a elevation for the electrical room, we can see the electrical room too. And here we have more electrical components. Like before we make a circuiting, correct? A2, A1, like that circuit. Here also we can see the circuiting. In the top area, the light was, I will select the light, and the electrical circuit A2 light. When we are going to see the floor plan, it is in the light. What we are making before the A2 light is. So now we'll import the model into the sheet. Just same method, drag and drop method. I will just select and I will drop into the sheet. And now it's a little big. We will reduce the scale. We can reduce the scale in the bottom. In the bottom, we can see the scale. I will reduce now. You can see the scale overall. We can adjust the scale based on the title blocks. I think now it's we can fit to the title block. I think it's good look. For example, we are showing the sheet setup. we can change the paper size. So in this Revit, we can create a section, 3D model, floor plan, discipline wise we can arrange it. So we can create a automated panel schedules. This is a future tool for Revit electrical. Moving to the next slide. Documentation and schedule. Panel schedule. In the demo video, we seen the automated panel schedule, correct? So we are just within single click in the panel, the generated the automated schedule. The sheet setup, we just drag and drop the sheets to the model to the sheets. So plan view we done. So detail view we can do. The SLD also, it's a drafting, we can do it. And the few formats we see in the export like TWG or PDF, or if you are going to send a Revit model, we can do the with the cloud system. So moving to the next slide. Interference check. In Revit, we have a separate tool for interference check. During the design stage, we can identify the classes. For example, the right side image, we can see the duct, correct? So the orange color was duct, the white color was conduit. The duct clashing with conduit. So we can remove the clash in design stage. During the construction stage, we can reduce the cost and time. Radish?
Yeah, thank you, Vijay. The demo was fantastic and very insightful, and the output you shared gave us a clear picture how the tools and the workflow can truly transform electrical design in practice. So we now reached the Q&A session. We received a few questions during the webinar, so we will start with those first, and after that, you are welcome to unmute yourself to ask or type your queries in the chat box or send them us via the email address shared on the screen. So Anant, can you go through
Yep.
the questions? Yeah.
Sure, Pradesh. So first question is like we use AutoCAD for electrical projects. How can Revit support better? So to answer that, in AutoCAD, you will be creating the drawing. Everything will be line based. So there are no 3D objects, or to be precise, no connected objects. Everything will be simple, created from simple lines. So what happens is in AutoCAD, the drawings will be not interdependent on each other. So if everything will stay separate. So if you have to make a change, you will have to go through all the files or all the drawings. So in Revit, what happens is like even if it is a drawing, while we are working, if we click that particular thing, it will recognize it as an object. So for example, if we are clicking a light, means it will recognize it as a light, and it will show all the properties which have feeded into that. So Revit will make your rework easier. You don't have to create a new link between, or check for connection between all the drawings. It will automatically update all your drawings as per the design change you are doing. So in that way, Revit is much smarter on such building information modeling process. So yeah, that is how Revit is better when compared to AutoCAD. And one more question we have, it is like are electrical components like lights or switches present as default option in Revit? So as we saw in the webinar, lights or switches are present as a separate component. Yes, it is present, but for example, if you take a receptacle or a socket in Revit, it will come as a simple box. Data will be present, but the appearance will be like a simple box. So in our projects, we can customize it to real world appearance, like to show a switch or a 3-pin socket in that receptacle. So we customize it to just for the visual appearance. So at APA, what we do is like we have a separate library for all the electrical components we majorly used in our projects. So we can easily plug and place everything into our projects. So we maintain a individual library for all these electrical components, which is custom built. Yeah, yeah. I think only those were the questions.
Okay. With that, we now come to the vote of thanks. And before that, let's all take a moment to appreciate our speakers, Ananthakrishnan and Vijay, for the fantastic session and the valuable takeaway that given us today. So, on behalf of all of us at AP Engineering, thank you so much for joining this webinar. And we truly value your time and interest. And we hope the session gave you useful insight into the possibilities of building information modeling. And as we conclude, you will receive a short survey, and we greatly appreciate it if you could take a moment to share your feedback, suggestion, or comments. And your input help us keep improving and deliver even more value in the future. And thank you once again, and we're looking forward to stay connected.